Hey, good morning.
Jeff, Luke from our team is supposed to attend, right?
Yes, but he's not essential here.
Oh, there he is. Yeah, I'm not sure who all from regulatory is coming, but it seems like we have a good crew here, and it's 10 o'clock.
Might want to give it a few more minutes. I think on the invite, Caitlin, there were several more folks.
Okay.
And as I mentioned in the email, we'll record it for anyone who was not able to attend.
Yep. I'll pull up the presentation. Okay, can you see my slides?
Yes.
Yes.
Okay. So again, my name's Caitlin. I've been with the Risk and Decision Science team of ERDC for about 2 years. I completed the past two cumulative effects analysis for like this new round, which was Maine in 2020, last year, and then Connecticut this year. But I'm leaving the team to actually join the Air Force as an officer. So I need to pass this information along. Big changes, yeah.
So you go straight to officer? I mean, have you been a member or something, or how does that happen?
No, I have a college degree. So yeah, it's just something I've always been interested in. I come from a military family, so it's just something I was like, oh, let's see if this will work out, and it has.
Wow.
Yeah, I know, big change, especially from what I'm gonna like talk about today with this cumulative effects analysis. Yeah. So I had to pick it up fairly from scratch, just with the help of Mike Narcissi, but also from all the documents he and Christy had put together from the previous round of this, which was from I believe between 2015 and 2018. So I wanted to try and help avoid sort of all of the piecing together that I had to do, and try to pass on some of this information before I'm gone, which is soon. Yeah. So also, of course, we have people from regulatory, but then we also have people from my team. So people are going to have different knowledges on this. So some of this, I'm sure, especially regulatory, will already know about, but also just for my folks and whoever takes this over next, I wanted to just touch on some basics. So the general permit, USACE has jurisdiction under the Federal Clean Water Act to sort of oversee different projects that happen in aquatic environments. And one of those permitting mechanisms is the general permit, which is issued every 5 years, and then projects can be authorized under the general permit with the assumption, essentially, or validation, that they're going to have a negligible impact on the environment. Those projects are tracked in ORM, and then it's reissued every 5 years. So every 5 years, we have to do this cumulative effects analysis as part of the reissuance of the general permit. And what we're trying to look at is, so the individual projects, which are allowed and permitted under the general permit, are supposed to have negligible impacts, but do they have a cumulative impact on watersheds? So that's the goal: evaluate the cumulative impact of activities authorized under the current GP on watersheds. The method follows, as I mentioned before, Christy Furin was a member of ERDC who left before me, so a few years ago. And then Mike Narcissi, I believe at the time was working in regulatory. He has since moved on to different positions. He's been a helpful resource for me, but I feel bad whenever I have to pull him back into this stuff. So he can be a good sanity check, especially with the final reports. But this is no longer his job. But either way, they wrote a white paper in 2015, which was very helpful to me, the cumulative effects assessment for issuing general permits in New England. So that's the methodology I was told to follow. So that's what I did follow, and that's what I'm going over in this presentation. And then the outcome of the cumulative effects analysis is a pretty short report, normally only 2, 3, 4, 5 pages, where you are summarizing the watersheds of concern, so whatever watersheds stuck out during this analysis that might need further scrutiny or increased protections under the new issuance of the new GP. So new rules that might be written into whatever that looks like. So the CEA is important because, first of all, it's a requirement. The states have to go through it in order to reissue their general permit every 5 years. It identifies watersheds that may have been inadvertently harmed in the past so that we can take measures now under the new GP to prevent further harm. These are some points that Mike made to me. He's, I think, he is more familiar with the other side of it as well. I am tasked with just the CEA, so that's what I do. But as someone who's outside of regulatory and doesn't have all that knowledge, I don't actually see the follow through or the other side of it or the actual implementation. But yeah, your analysis, the report, all of it is only going to be as good as the available data. I'm sure anyone who has worked with data in any capacity knows that that's true. So accurately collected data as collected and then reported in ORM will determine just how useful and accurate the CEA is. It's good to take time to reflect on. So once you finish the CEA, take time to actually reflect on, do the results make sense given recent permitting actions? And this is something that I couldn't really do. I could, validate that my equations and the numbers made sense, again, based on like what was in ORM, maybe, recent knowledge of rainfall or, just very basic surface level things. But as someone who's outside of regulatory, outside of the district, I don't have that firsthand knowledge of recent permitting actions. So that's something that a regulatory could definitely bring to the table. And then finally, how will the CEA actually be utilized to inform the renewed GP? And again, that was always out. I would pass off the report and that was that. But someone, more connected might use the CEA to not just check that box, but to actually maybe use it to justify pre-construction notifications or special area management plans in those identified watersheds. Obviously working with the state, working with stakeholders to figure all that out. Sometimes it does feel like it's just a checked box. That's a vibe that I got a few times. But it can be more. Yeah. And I also wanted to I'll be sending out a zipped folder. So you'll have much more than just this presentation, because yeah, there's a lot of fine points that I'm sure I'll miss, or that just like you'll want references for. So in that folder is all of the previously completed cumulative effects analysis. So the ones completed in 2015 to 2018. They can be pretty helpful as both examples to base new CEAs off of, but then also to compare previous results. So what watersheds were previously identified and why, to whatever the results of your current CEA may be. The next folder contains the ones that I've done in this round, so post 2020, which will be Maine and Connecticut so far, which again, they might be good, hopefully, examples for the next 4 that need to be completed in this round. I also just wanted to note that there might be hidden tabs in those Excels just for organizational sake. So you might need to unhide them. And then the last folder, and I think the most helpful folder contains a few guides. So it'll contain this presentation. It contains the white paper I already mentioned. It contains a guide that I wrote for myself, also with the idea of hopefully being useful to someone coming in. And then a few other references like important score tables. Yeah. And then if all of that's not enough, which hopefully it will be, there are 5,000 plus files from the previous round and I think creation of the CEA and its methodology, which is on a purple hard drive down in our office in the basement of ERDC. Yeah, so Chrissy Fern was the one who did all this originally. All of her files still exist. A lot of them are GIS files. But yeah, that might, again, there's a lot of resources. It's just a matter of using them and which ones might be helpful. I also wanted to do a background on HUCs because this was something I needed to figure out. And again, there's mixed levels of familiarity and knowledge in this group. So HUC stands for Hydrologic Unit Code, and they're used to identify unique watersheds or surface drainage basins. So the report and this analysis, we're looking at the watershed level. So you have to be able to identify specific watersheds in this sort of standardized way. So the USDA has shape files that you can download that'll give you GIS, basically what you see on the right here. And the number that follows the HUC, so this is sort of like HUC level, you have your HUC 2s, your HUC 4s, 6, 8, 12, determine how many digits are in that unique identifying number. And the more digits, the more like zoomed in and specific you're going to get. So on the right here, you can like kind of make it out is New England. So this is a HUC 2. So it's HUC 01, New England. And as you zoom in your HUC 4, now you have 0108. That's the Connecticut River Basin. You add more digits, you zoom in further. You have your HUC 8. Now you're at your lower Connecticut, and that is the blue and black lines in this. And then you zoom in even further, HUC 12, you're zooming in even more, and that's all those little red lines. So different states have a preference for which scale based off of the previous round of CEAs. So for Maine, we did everything at the HUC 8 level, but for Connecticut, I did everything at the HUC 12 level, which obviously meant a lot more watersheds, but also more precise, especially when you're looking at the impact of permits. So you're looking at more specific area. So that's a HUC. And then the CEA, the cumulative effects analysis, consists of 2 primary components. They're tabulated and done separately. And then once you have those figured out, you bring them together to compare them again, at the whatever watershed level the state is interested in. So the first is well, you can do them in whatever order you want. One of them is the existing conditions assessment. It's scored on a scale, as you can see along the x-axis, from 0 to 1. Basically, you're trying to estimate the conditions of the aquatic habitats in each watershed, 1 being most pristine, 0 being most degraded. And then the general permit impact score, again, is trying to find out that cumulative impact of all the permits that were allowed under the general permit in each watershed. So that one on the y-axis, yeah, it's not normalized or anything, so that's why we see much bigger values. So each of those dots is an individual watershed, and then we're essentially trying to see, is there a correlation, and which of these watersheds would we consider, at risk for further harm or might need increased protection or increased scrutiny, or just different measures under the new GP. So first, also, if anyone has any questions at any time, feel free to stop me. Yeah.
I have a quick question.
First, yes.
Oh, sorry. So existing conditions assessment, is that's a crunched number? Is that what that is?
Yeah. So we're gonna I'll advance this slide. So the existing condition assessment is this weighted calculated score. Yeah, good leading question.
Yeah.
So again, it's a score from 0 to 1. Again, 1 being more pristine, 0 being more degraded. And so within that score, so the 0 to 1 would be like this full pie. And then a third of the pie is made up of water quality, a third on water quantity, and a third on habitat value to sort of make up the overall conditions. And you can see that within those criteria, the sort of proxy or sub-criteria that are used to evaluate those, water quantity just has the 1, it's flow. And I'll go into more detail in each of these in the next slides. Water quality and habitat value are both made up of 2 different sub-criteria. So each of those get an equal weight of their slice. So each of those is worth a 1/6 of the final score, whereas flow gets a full 1/3 because it's the only one in water quantity. So those are kind of like the weights and sort of what goes into that final existing conditions score. So starting with water quantity, specifically, it's the average annual flow rate as a percent of the historic baseline. So essentially what we're trying to get at here is, has there been a change in flow in the past 5 years when compared to the baseline? So do we have more water flowing through? Do we have less water flowing through? Because both of those could have negative environmental impacts and could be the result of a lot of things, not just permitted projects within the watersheds, but again, it's a proxy and what was determined previously. So that's what we're going with. This data is downloaded from the USGS WaterWatch website. There's a link at the bottom there. Essentially, they have a bunch of stream gauges across the country, and they calculate flow at the water year level at HUC 8 or higher. So I think like HUC 2, 4, and 8 is what they'll do. And it downloads as one giant CSV file. So you'll have to go in and pick out the specific watersheds that you're interested in. So whichever ones are in your state, those are the ones you want to choose. And then you divide you average the last 5 years, then you average the previous 50 years, and you divide those two together to get the percent historic flow. So just the example from Maine, 2015 through 2019, and then 1965 through 2014. And so WaterWatch only calculates to the Huc 8 level. It doesn't go further. As I mentioned previously, Connecticut wanted to look at the Huc 12 level. So that means that you either need to download the data for individual stream gauges, map those onto the Huc and do the calculation that way. And when I looked into doing it that way, there's a bunch, like a ton of Hucs that just don't have even a single stream gauge in them. So it would have been a lot of missing data that would have been filled in. I'll go into this a little later, but filled in with kind of like the mean value of the surrounding Hucs anyway. So what I did instead was to, again, since Hucs are nested in with each other, you can look at the first 8 digits of a Huc 12, see that, okay, that's its Huc 8, and then just apply the Huc 8 flows to the Huc 12s contained within it, or the Huc 10s, whatever level you're doing. Yeah, so again, just working with the available data the best you can. The next criteria was water quality, which again has 2 sub-criteria. So you have your coastal water quality. So that comes from the EPA's National Aquatic Resource Survey. As of the Connecticut CEA, which was done earlier this year, the most recent data was 2010, which is obviously outdated. So hopefully, I don't know if they're going to publish a 2020 soon. I don't know how often they do that. But at least, and this is something I'll also like mention in the report, just so they know it, like, oh, this data was last updated in 2010. So take it as you will. But it's downloaded again as a CSV from the website along the bottom. And specifically, I think it was a CSV. Yeah, because a CSV contains coordinates in addition to, a bunch of other stuff. But the category or the column that I was most interested is this CAT WQI, so water quality index. It's classified as either good, fair, or poor. So I used ArcMap to take those coordinates, map them onto the Hucs, and then see which ones got good, fair, or poor, which you could then, give a score of 1, 2, 3, or however. The second indicator within water quality is inland water quality, which comes from the 305B assessments, which I believe the state does every year and then gives them to the EPA. So they're typically done for rivers and streams, lakes and ponds, and estuaries. And the formats differ between the states, in which case the way you're going to access that data will be different. So for example, Maine had all their data in PDFs, so I had to convert the PDFs to a Word doc, copy and paste all those tables into Excel, and then sort of tabulate, calculate, divide the data that way. Whereas Connecticut was in GIS layers, which made it a lot simpler, because then you just had, map it onto your Hucs, and then, add, divide, all that stuff. So again, it's going to be different for every state, and so I don't have a link for that one, but it's the 305B assessments. So within those assessments, it gives you generally the name of the water body, the acres that were assessed within that water body. So acres if it's a lake or pond or estuary, miles if it's a river or stream. So it gives you that information, and then it tells you whether it was impaired or not impaired. Generally, it's just binary. And again, the reports look different, and how they say that might be different. So you might have to kind of first figure that sort of language out. But yeah, generally a water body is given a use designation. So whether it's for drinking water or recreation or cold water fish habitat, and then it'll tell you, well, did it meet that designation? And if it did, then it's good. And if it didn't, then it's considered impaired. So when we're looking at the percent of waters that are impaired, we're looking at the percent of assessed waters that are impaired, because in a given year, a state with its limited resources can't assess all of its waters. So you first have to add up all the acres and miles that were assessed within each watershed, and then how many of those were classified as impaired. And that's how you get your percent of water impaired. The next criteria is habitat value. This one also has two, but I split it into two slides. So the first one is land use. This is a land use cover raster file, which can be downloaded from the USDA Geospatial Data Gateway, which is also where you get your HUC shape files. Since we're interested in just the percent developed, the original raster file has a lot more detail. So the first step is just reclassify so that you have just your open water, your developed, and your undeveloped. And then you divide your developed land by your total land. To get your percent developed is your raw score for land use. And then the second sub-criteria within habitat value is stream discontinuity, which means the number of stream crossings. There's an organization called the North Atlantic Aquatic Connectivity Collaborative, which is both a mouthful, but they track stream crossings within all of the New England states. And they have both shapefiles and Excels of the stream crossing data for each state. So you can do Excel, and I don't remember if the Excel included the HUC information or not, but you can load that JS file into ArcMap or another GIS platform to then join it with your HUC layer, and then you get the number of stream crossings in each HUC. And the link for the NAACC is at the bottom of this slide, and also in some of the guides in the folder that I'll be passing out. So once you have your raw scores, you have to normalize them, again, on a scale from 0 to 1. So this is an example of the first 4 HUCs based on number for the Maine 2020 CEA. So we can see that on the left with the first 5 lighter columns are just the raw scores. So your percent impaired, your percent developed, all that is just the raw true value. And then on the right, we have the normalized values. So for the majority of this criteria, higher values were considered worse. So, more impaired water, more developed land, more stream crossings is going to be considered worse, more degraded than ones with fewer. So I'm sure also a fair number of you are familiar with how to normalize scores. But I threw the equation in here just in case, and the equation is also obviously contained within the Excels, which can be used as examples. Flow was a little different. Previously, in the previous CEA, all of the scores were actually above 100%. I don't know if it was just an especially wet 5 years. But with this CEA, we had scores both below 100% and above 100%. So some watersheds had less flow, some had more. So what we decided was that values further from the baseline, which was 100%, were worse than values that were closer. So the greatest difference, whether it was above or below, got a 0, 100 got a 1, and all other scores were compared and assigned a value between those two. And then obviously a lot of watersheds are not coastal, and therefore they don't have a coastal water quality indicator. So according to that original white paper, it had the phrase, mean value of available data was used as a default value for other watersheds. So in Maine, all of the coastal water quality sampling spots got a score of good. So everyone got a 1. So everyone we just filled it in accordingly, because otherwise you're going to artificially inflate or coastal watersheds would have gotten a higher final score simply because they had this coastal water quality score to like fill in and like add that bump. So everyone got a default value. So once you have your normalized scores, you use the weights from that first slide, as I was talking about, that pie chart. Each of these criteria account for 1/3 of the overall existing score. So that's why in this equation we have 1/3 at the beginning. And then for both water quality and habitat value, both of those sub criteria account for half of that criteria. So we have 0.5. So that's how we got the scores here. And you can see for like the Allagash, they had no impaired water. They, obviously they weren't coastal. Everyone got a 1 there. So they got the perfect score of 0.33333. Yeah, and then you add those all together to get your overall existing condition score. And that's your score for the assessment. And again, just a kind of visualization of the variety or kind of just differences in scores for all the main HUCs are included on this slide as well. So I believe, yeah, that's the end of the existing conditions assessment. Are there any specific questions here?
I have a question. This is Paula. The water quality component you referenced for coastal EPA's National Aquatic Resource Survey, and I guess it's classified as good, fair, or poor. It would be helpful to know kind of what's embedded in that, because does it take into account impervious surface area? Because that is going to be, I think, probably pretty important in analyzing water quality, because it will affect things like temperature, flow rate, ability to percolate into the soil and, filter that way. So I'm wondering if there's a, like an appendix or something that you could attach that would, provide a link with maybe some bullet points about how those assessments, how those good, fair, poor assessments are acquired, because it might tell us how much of our work would be, what permits we issue might affect those. It would intuitively tell us whether there are things about our permits that are likely picked up by that data set or possibly not. And it seems like impervious surface would be a pretty important one, for all the reasons I mentioned, affecting flow rate, runoff, flashiness, erosion. So that would be something good to know, if you could give us, some kind of an appendix or something that gives us some little summaries or links to how that's obtained.
Yeah, definitely. It's been a while since I read into the National Aquatic Resource Survey, especially their coastal one. They do have a big, giant report on sort of what went into that stuff. I don't think it included that sort of like impervious cover and whatnot. it looks like they have, you know, off the coast, like in the water, sampling locations where they'll look at things like, you know, nutrient levels, maybe like heavy metal toxicity.
Well,
Maybe
sure,
like what?
in the when you're out and taking samples in the waterway, but I was thinking if you're taking, if you were looking at water quality, that's going into the runoff, you know, from sites into the runoff. I'm just wondering, you know, because that would also maybe cover things like turbidity, because if it, you know, if the water is percolated through the soil, by the time it gets to the stream, it's probably pretty clear. But if it's, you know, say you got a bunch of sand washed onto a parking lot, and then that washes right into a stream, and, you know, or fines, you can get a lot of turbidity. So I'm just, you know, if there's just some way we could know what is contained in those water quality indicators, that would give us some way to, you know, maybe understand better what the results mean in a little more detail.
Yeah, definitely. I can find that report again and include it into the folder that I'll be sending out. I know that yeah, it's obviously you know, runoff and impervious cover and everything is a
Good.
huge
Okay.
impact on water quality. Yeah, it is included or attempted to be included with this within habitat value.
Okay. So how does
yeah.
that differ from the National Status and Trends database? Did they rename it? Because well, National Status and Trends, I know people at NOAA headquarters were involved in developing that. I don't know how that differs from the EPA's National Aquatic Resource Survey, because I mean, I haven't heard of the EPA one, but I had heard of National Status and Trends.
Yeah, I haven't heard of the National Status and Trends, and honestly, if it's more updated, it might be a good resource to use instead. Again, I was following pretty strictly the methodology that was laid out in front of me, and this is what they referenced. But like, if that data source has sort of similar indicators, similar things feeding into it, and is more updated, it probably would be a good resource to use instead. I just didn't know about it, and I think I was too like, this is my path, this is what I will follow.
Well, I think, you know, for comparability, if you're using a particular approach for all those other years, and you want to be able to compare it, you know, over time, which is cumulative effects, then I can see why, you know, that you wouldn't deviate from that. But you know, it might be a useful thing, you know, to say, you know, additional resources at the end that could be compared to, just to see how they jive, and if there's anything that jumps out between, you know, the National Status and Trends versus what we're seeing in our region, that kind of thing, as another way of looking at the results from this.
Definitely, yeah, it could be like kind of like an attached or yeah, an additional thing, like how do the scores differ, and therefore how does the outcome differ when you use these two different resources, would be really interesting.
Because I know they've been collecting that data for years and years, a long time.
Yeah,
so
it sounds useful.
You could go back in time and look, maybe, if you know, not you per se, but whoever takes on the next round, I guess.
Yeah. Yeah. Are there any other questions related to the existing conditions assessment? Okay. So the second component of it was the general permit impact score. This one I was finding a little more complicated to sort of concisely give an overview of, but essentially what we're trying to do, as I mentioned before, was to quantify the cumulative impacts of GP authorized activities. Again, on those three separate criteria, your water quality, your water quantity, and your habitat value. So each of those things get their own impact score, because a single project may impact the water quality differently than how it would impact the habitat value. So they all have a different table. So here, this is table 3, water quality impact scores. So there's a separate table for water quality and habitat value. And these tables were created again in the previous CEA cycle and method creation by my predecessors and expert opinion, I believe, to essentially for each activity type, which is above on the columns in this table. And those are the activity types that are listed in ORM. So for each of those activity types in each of the aquatic habitat types, also known as Cowardin, I always mispronounce it, but the Cowardin classes. So there's examples of those in the rows. So for each of those combinations, would we expect that project to have a high impact, a medium impact, which would get a score of 2, or low impact, which would get a score of 1. And then also, as you can see in the table, there's X's, which means that we don't expect an impact. So if you're doing the discharge of fill material into the estuarine intertidal, that got an X, meaning no impact or indeterminate impact. Yeah. So what you need to do is to find out how many projects in the last 5 years fell into each of those combinations within each watershed, and then multiply it by that impact score, which then you can add up to get the overall impact score. So I try to include some, simple examples. So if we have 4 projects, that 4 discharge of dredged material projects in estuarine intertidal habitats, that got a score of 3. So 4 times 3 is 12. So same thing, marine intertidal discharge of fill material. You have 3 projects that got an X, so there's no impact, gets a score of 0. Marine intertidal dredging, score of 1. Multiply the number of projects by that score to get that sort of sub overall score. And then ecological restoration is an interesting that I wanted to point out. You can see that it has negative values because it's actually expected, restoration to have a positive impact. So if we have 2 ecological restoration projects that were done in estuarine unspecified habitats, that got in the impact score table is a -2. So 2 times -2 is -4. When you add it all together, 12 plus 3 minus 4, you get a score of 11. So that would be the water quality score for this imaginary watershed. You would then go through the same process with the water quantity and habitat value tables to get your overall, add it all together, you get your overall impact score. It's both, I think like it was hard for me to first like conceptualize and be like, okay, but then kind of like simple the more you think about it. And these impact scores, there's a separate document in one of the folders that I'll be sending out called impact score tables. I believe they're also in the white paper, and they're also in the guide that I wrote. So there are multiple places because they're very important. So before you do all of that, you kind of have to prepare the data just for conciseness. And again, this is just the way it was done previously, so I'm following what I was told. So you ask the state for all of the information in ORM for the period that you're looking at, so the last 5 years, whatever that date is that they last reissued, to whatever date it is now that you're doing the assessment. The most important columns that I found are the work type, the HUC number, depending on what level you're working at, the coordinate class, which again is the habitat type essentially, the activity, which will be conversion of water types, dredging, whatnot, and those including area if you're interested in adding together the area that was impacted. So you reclassify the coordinate class and the activity just for conciseness. You can see that most of them are just kind of like a shortening of the phrase. A few of them get combined, like a lot of these palustrin sub-coordinate classes just get combined in palustrin unspecified. Other work and removal gets just combined into other. The full tables of these are in both the white paper that was put together and then also the guide that I wrote, which will again be in the folders. So you have all the data, how you need it, and then again, you're following the steps I sort of already mentioned. So the overall score is the combination of the water quality, and habitat value impact scores. So you determine the number of projects for each activity type and coordinate class combination for each watershed, multiply the number of projects by the corresponding score in the water quality. For example, the water quality score table, you sum all those scores within each watershed, and then you repeat it for the other two criteria, put them all together, get the overall impact score. The way you do this is up to you. There used to be an Excel macro that was pretty nice, actually. You copy and pasted or just moved the tab from whatever Excel the the state gave to you into this macro. You press run and then it spits out all the scores and sort of even more information, but it seems to be broken. It was developed previously in the previous assessment. I got to work for Maine. I was double checking everything because originally it changed the impact scores. So then I had to change those back. And then it did work. I checked a lot of the watersheds to be like, okay, yes, this does make sense. And then when I tried to use it for Connecticut, it was just completely broken. I don't know if it has something to do with how just the macro functions or the way, you can't even use macro on government machines anymore. So it was just being more trouble than it was worth. So instead, I used a series of pivot tables and different formulas to take the data from Connecticut and calculate these scores. So that can serve as an example that you can go off of. That'll again be in the folders that I'm gonna give out. And then, but also, if you're savvy with R or other, coding languages, once you have the data and you know what to do with it, it's relatively, shouldn't be hard, especially if you know how to code, to sort of do those calculations to get these final scores. So unfortunately, the macro is broken. Huh?
I don't think any of us know how to code.
Oh, well then the example of pivot tables and formulas will be especially helpful, I hope.
We'll have to send that to headquarters or something, probably. Tammy will have to figure how we do that.
Yeah. Again, it wasn't, I have a very weak coding background. I know how to use R, but even with something like this, I wasn't fully confident in my abilities to use R to do this. So I used Excel and it worked pretty well. Yeah, it sounds like that macro would have been really helpful, but I have no idea how to work with macros or fix macros or go into it and see what's wrong. So
it could have to do with different software upgrades and how how it may just not, legacy files. Some of our legacy files, when we got upgraded, we have to do a specific step or make some kind of a request in order to be able to use legacy files. So that could have something to do with it.
That's what I was thinking too, because it worked well for Maine back in like 2020, but then yeah, we had all these sort of like upgrades, changes, where it like didn't work anymore, but also didn't work on my personal laptop, which I think still has the older Excel on it. But either way, yeah, once you sort of like understand the steps conceptually, it's not that hard, but it is, since you have so much data in these 3 separate tables, it definitely helps to be able to use some form of formulas. Yeah. So again, hopefully and those formulas are included in the Connecticut 2021 CEA. You just like click on a cell, it'll show you the formula. But even that, some like manual work of me just sitting there and going row by row or column by column still went into it. So it was a little harder than last time. So once you have your final GP impact score, your existing conditions assessment, you're comparing them against each other. Now you need to determine what watersheds you're going to point out or specify in the report. I think this is like something that definitely, you know, regulatory or just like other people who have a better idea of the actual happenings of those projects might be hopefully be better at. I found it to be somewhat subjective. You know, our first conversations with Maine, I was asking them, okay, are you more, should we try to protect watersheds that are, you know, pristine so that they don't get further degraded? Like, do we look at degraded watersheds and say, oh, well, they're already degraded, so like more projects won't matter? Or do we look at those and we say, oh no, we want to protect those? And they just looked at me and said, well, it's up to you. I'm like, great. So I looked at, you know, the previous CEAs, or like what their reasoning was, what their thought process was, as much as I could with the legacy files. And so again, it is somewhat subjective. I didn't get much state input, but as long as you justify in the report, you know, these are the selections I made, this is why I made them. So this is an example from Connecticut. In the red, you know, there's 5 dots. Those 5 watersheds were in the bottom 5% of both existing condition and GP impact score. So I was like, okay, these are the most concerning. And in the yellow, I have watersheds that, you know, didn't have a very high impact score, but they had a low existing condition assessment, or maybe they had a lot of impacts, but they were sort of moderate in their condition. So I looked at those and said, you know, these might not be of immediate concern, but like I'm still pointing them out, getting them on your radar, and like in the future, they might become concerning if, you know, trends continue or if you increase impact. Yeah, so it's just a lot of, this is what I decided. This is the trends that I'm seeing. This is why. So in the text, I gave a lot of details on what types of projects were in those watersheds and why they scored poorly, how they compared to the average or just other watersheds. Yeah, so just being like clear and concise with your decision making in that report is important. So the final report, I mentioned it's a pretty short report, honestly, just a few pages long. It can be as long as it needs to be. I think I started with some reports I saw previously were like 2 pages. And I think the one I did for Connecticut was maybe 4 or 5. And then I included an appendix of like all the watersheds. There was like 180 some HUC 12 watersheds and all of the scores that they got, just again for sort of transparency's sake. So I generally, and again, there's examples in both the old CEAs and the CEAs that I recently completed. I start with a opening overview paragraph on the CEA process, the purpose, the time frame we're looking at, all that stuff. I then say which watersheds I've identified and why. and then the specific details on the composition of permits, both at the state level and the identified watersheds. So for the state level, how many permits were issued in this 5-year period, what percentage of them were in those different activity types. And I normally do, or even include a table of the same thing for the identified watersheds. So, how many permits, what activity types. And then for those, I also go into specifics because the work type column within the ORM data set goes beyond just, dredging, discharge, fill material, ecological restoration, and will tell you things like, oh, this was for residential piers or culverts or the creation of, a multi-family home. That sort of information was, I think originally I didn't include it, and then Maine asked for it, so then I included it in Connecticut as well. I think it's very interesting to them to be able to look at what specific permits actually went into each of these watersheds that we're worried about. Go into similar detail on the existing conditions assessment. Again, for transparency's sake, I normally say, this is the criteria we were looking at. This is where the data came from. The data was last updated in 2010 or whatever. And then how did the watersheds of concern rank on that condition? So pointing out ones that was like, oh, all of these had the lowest or worst flow rates or the most stream crossings. Compare it to the state average can also be pretty interesting. The comparison to previous CEA, Maine did not ask for this. They weren't interested in it, but Connecticut was. So they wanted us to look at what watersheds were identified in the previous CEA, and then, were the same ones identified now? Why were some no longer identified? Some had better conditions. So I was able to say, oh, these weren't identified. The ones that weren't in this CEA but were in the 2016 CEA are because, okay, they had better conditions, or, oh, these had worse impacts and that's why they're here now but not previously. So again, that's kind of up to the state. It sounds like states are interested somewhat in different things, so just having those conversations with them can be pretty important. And then end with a conclusion paragraph. Include, again, just restate what you've stated previously. Generally, again, if you looked back at the graphs I showed previously, you can see a correlation. You can get stats for that correlation. Generally more impacts, lower assessed condition. So we can say there's a correlation, but I'm sure, as you all know, correlation does not equal causation. And that's something that I also like to put into words there, where, illegal activities happen. USACE doesn't have jurisdiction over, everything. There's other avenues. In the main report, I even mentioned explicitly, because I'm signed up for the monthly digest of the Maine Department of Environmental Protection. So every month I get a PDF of, all of these things and fines that the state has put out for, people who just dumped a bunch of sand in their lake to make themselves a beach, or some company wasn't meeting their discharge limits, so they were polluting more than they should have been. So again, just because the degradation habitat that we're seeing is not necessarily caused by GP permits. We're trying to see this comparison because it's the best we can do, but we'll never know all of what's happening. And I think that's important to think about and state, but also that it doesn't invalidate the CEA, and that it's still important to reduce our potential to make harm where we can. And I include both the scatter plot that I showed here, and also a map, generally, again, created in ArcMap. So again, with Connecticut, you can see that I had my most concerning. So those were the bottom 5% each. And then I defined this in the text, most degraded, most impacted, like what that actually meant, what I was pointing out. But so those would be the ones that most degraded, like, okay, they had low condition, but pretty low impact scores. And then most impacted, they had, high or moderate impact scores, but pretty average conditions. So just a few ways for the state to like visualize the data. Yeah, that's the end of my presentation. Are there any questions on the impact score part, or I guess any other component of the cumulative effects analysis?
This is Paula again. Just looking at this result map, I'm wondering what's going on in the upper center there, where you've got those two like watersheds adjacent to each other, and all around it doesn't look like there's, I mean, it's not like there's not surrounded by orange or whatever. So most concerning is, so that's not necessarily the most impacted, it's the one where we're seeing the most change, is that right? Maybe the rate of
most
change?
Concerning, yeah, was defined as they were bottom 5% of all watersheds in both. So they had, I guess, okay, top 5% of impact scores, and then bottom 5% of existing conditions. So they were both highly impacted and highly degraded.
Oh, so most concerning is a combination of those orange and yellow.
Yeah.
Okay. I guess so. Again, that makes me wonder why those red areas up in the middle kind of, when you get down to the coast and you know that there's drainage from, industrial areas, but I thought maybe, is that near Hartford or something? Is that kind of maybe, I'm trying to think what's up in those two areas.
Yeah, and that's sort of where like my knowledge ends. When I was doing the state of Maine, I had a lot more personal insight because I'm from Maine. So I could look at things and be like, oh yeah, that makes sense, or like, oh, that's kind of surprising. And yeah, so like, yeah, I stuck to kind of like what I was told to do. I was told to do the CEA. Those conversations with the state afterwards, or with people, again, who maybe have more knowledge of the permitting system and all that stuff, would be really interesting to actually like see what their conversations are like once they see this analysis and see this map, and now they're talking about the next GP. Yeah, because again, I'm also like, I have no idea what's in Connecticut, where it is. Yeah,
I guess we'd have to kind of overlay it on. I don't know if we can. I guess I don't know if we can import this result into ORM at all or not. But I mean, we could try to overlay it on another map just to see what the cities and towns are that are showing those most concerning areas, especially away from the coast where we might not be as familiar with the names of the watersheds and stuff. We have a lot of coastal projects. We have a lot of coastal projects, so we don't necessarily run across some of those other areas as often, and it's not quite as familiar.
Gotcha. Yeah, Maine actually sent me when they finished like the new GP and everything, they actually sent me the final GP, but I'm like, I don't know how to read this or like how it was different, because it's that technical or regulatory. Yeah, and I was like, thank you for like thinking of me. But yeah, my does not, my expertise is
that's the
hard.
bureaucratic layer piece. That's what that is.
Yeah.
Thank you for doing all that. It's I think it's hard to it's hard to take these 5-year snapshots when we all know, like, within any given few months or a year, we've got so many different software programs, and then we got staff turnover, and so it's a little bit like following a breadcrumb trail, I think, to try to try to sort through what they did and then how it relates to what's available now. So it's challenging, I think.
Yeah, it definitely was, which is why I was, when Jeff mentioned, can you give a presentation on this to, both you guys are regulatory and our team, since we don't really know, what the future of the CEA will be. It's like, let's just get this information recorded, down somewhere. So that there's less of a breadcrumb that people have to follow. I'm sure there will still be things that I've missed but at least now it's like, okay, this is where the resources are. And this is the general theory, thought process, behind it all.
Yeah, that's really helpful to kind of lay it out in a little bit of a framework and the moving parts, and that way we can sort of step back and maybe take a bigger view of how things have changed, and then how the databases might change, or I don't know. It's like you said, it's I mean, even with us, with our database that we have, I mean, when I first started working here, probably when you were a child, we had a totally different database, and then we had to copy everything into the new one, and even though the program had been around for, I don't know, at least 20 years or more, I guess, then when we put it into the new database, there was quite a difference in availability of data, how things were recorded. And so it's not an easy adjustment, I think, when there's so many different parts that you have to kind of get your arms around to think about how they're best represented. So I appreciate your efforts.
Thank you. I appreciate it. Yeah.
Hi, Caitlin. I have a question.
Of course.
You did the Connecticut CEA recently, and that was for my branch, Connecticut, Rhode Island. So thank you for doing that.
My pleasure.
And pretty soon I'm going to have to do the same thing for Rhode Island as well, because we're going to reissue the Rhode Island general permit early next year, 2022. So so you're leaving ERDC, I guess, and so for the next one, we are going to do this ourselves. Is that how this is going to work, or is there still? I mean, is that the point of this training, or is there still assistance at ERDC for the next CEA? The next CEA will be mine again, I think, in Rhode Island. So.
Yeah, so I think that's something that ERDC and the district are figuring out.
But just to chime in here. So yeah, that is the point of this training. To answer your question in a nutshell, we originally, this was, as Christy mentioned, Caitlin mentioned Christy Ferran many times during her presentation, but she picked it up from her. Originally, it was just ERDC's involvement was just to come up with this methodology and for it to be used by you all folks. But over the years, we ended up doing the analysis as well, but there's just not the resources or the kind of the know-how now with Caitlin leaving on our team. So even if Caitlin is gone and there are questions, we'll certainly still be here to try to help folks along through it. Although we'll be referring to the same documents and this training that is recorded as folks on your end would be as well. So there's no, with Caitlin leaving, there's no more in-house knowledge of doing this, and so hopefully the methodology that she's established with the documentations and supporting materials and this training video will be enough for anyone on your end to pick it up. Over.
Okay. And Caitlin, did you say you were going to email all the participants the information? Okay.
Yeah. Yeah. I haven't looked at who's on the calendar invite, but also if I emailed it to Tammy, could you distribute it to everyone?
Caitlin, I can send it to everyone on the invite because I have that material. We can also upload the video to YouTube or some streaming service so that you don't have to deal with a multiple gigabyte file. And it's always available.
Is there some kind of an SOP or something for this where it says like the first 10 steps are 1, 2, 3, 4, 5, something like that? Some kind of user-friendly manual or procedure or anything? Because when we do it, we'll probably be doing it for the first time, sort of. I mean, I think we will be doing it for the first time. So.
Yeah. So when I was writing the guide, both for myself and in my mind being like, I'm not gonna be around to do this forever, I did try to lay that out in steps. And the white paper I mentioned was also pretty helpful with sort of steps. There's no sort of like formal or like kind of how we're used to seeing an SOW or SOP, at least not that I found, 2 years ago. But I definitely tried to lay out those steps and the process, and sort of reiterate from other resources I was looking at and pulling that into sort of one guide. So hopefully it's clear.
Okay. Okay, sounds good.
If it's not, we still have Caitlin until December. So
Thanksgiving.
Until end of November. So there is time, to add clarification if you look over the documents and you need a different format or some sort of cheat sheet about steps 1 through 10. We can definitely revise the documents so that they're most useful to you.
Okay. So we should look them over, and if there's any questions, we can reach out to Caitlin. Sounds good.
Sounds good.
All right. Thank you.
Thank you. Are there any other questions? Otherwise, we can end early.
There's nothing in the chat box.
Nope. Yeah, I was looking at that too. It's hard when you're presenting, it goes like full screen and then you can't see other people's like faces or the chat or anything.
I guess we're all set on our end.
I got a question over email actually from Frank. Frank, are you on this call? I'm guessing you're not the E6 number. So he asked a similar question about the transition. So Caitlin, when you send that out, we can be a bit more clear about the intention of this training and who's picking up this work and and to, you know, how to send questions or get clarifications before you go. So we'll make sure that we include those details in communication after this.
Thank you, Caitlin. I appreciate your efforts. I'm sure it'd be way harder for us to wade through this without you.
My pleasure. Sorry, I just had a Tammy sent a message. I was referring to the regulatory reps in each state. So not the state departments, but the regulatory reps in the state, which I never really knew how to refer to them. I was like, okay, they're in the main office of regulatory?
Yeah, main field office.
Yeah, sweet. The organizational chart doesn't exist, so I got confused.
Oh, uh-oh.
Or I couldn't find it as someone in ERDC, sort of outside of the district. Yeah, well, I appreciate everyone taking the time to listen and then all the thoughtful questions. I'll finalize the documents in the folder, send it to Jeff, and then Jeff will be sending it all to you. And yeah, I'm happy to make corrections or corrections. I can't think of the other word.
Or add clarification to steps.
Yeah.
Clarifications as needed.
Glad you offered to train Kevin.
Great. Well, thank you so much, Caitlin. Yep. We'll send out the materials shortly, and I appreciate everyone being on this call.
Thank you.
Okay.
Bye, everyone.
Meeting over.
Enjoy the rest of your day.
You too.